Again, welcome to our Biostatistics 1 class. Today we're going to discuss about what is mean, media, and also mode. So in this unit lectures, we're going to discuss about what we already discussed in our previous lectures. For example, finding the location, the shape, and also the spread. In terms of location is what we are looking for, the mean, media, mode. In terms of the spread of a distribution, we look for the variance or standard deviation or the range. So this lecture is going to focus on using a formulas or we solving it using the real values now. Previously, we used a graph, like stem plot can help us to find the media. The central location also, it can help us to find the spread. We may use something like a frequency distribution table or dot plot, etc. But this time we are going to use formulas or numerical summaries. So a summary statistics deal with central location. This is the part of descriptive statistics. We talk about the central location, we mean the mean, media, mode. And also we talk about the spread, how the data varies. In this case, we're going to find the range, interquartile range, or the variance, and also the standard deviation. Then the last part is the shape summaries. But we hardly use this in practice, especially in terms of using formulas or values, quantitative values, to find the shape of a we normally seldom do that. So let's start again. The objective in this section is the first part, which is the location or the central tendency of our data set. How to find the mean or what is the mean, media, and then the mode. So first we start with some few notations. Again, when we see a lowercase n, it means the sample size. For example, we have a population of 1 million people in New York City. That will be uppercase N population. Then we draw 100 New Yorkers from 1 million. Then 100 becomes sample size. So sample size will be N, lowercase n. X will be the variable. Our data set, are we collecting data set by patient's age? Then age is the variable, or the patient's weight, or the patient blood pressure. All these are variables, so it will be uppercase X. Then we also have a lowercase x sub I. This is the value of individual values in the whole variable. So for example, I have 20 patients with their age, which means I have 20 ages. One age, let's say one patient age is 30 years. That would be the X1. Second patient is 22, that's S2, etc. So that represents Xi. And we know our sigma symbol, that's for summation, sum of everything. So let's start with an example here. We have a data set here of ages, 21, 42, 5, 11, and etc. Now, when we count all the number of ages we have 10. And they told us this is a sample. So this means the lowercase n will be 10. The variable is age, the x. Then x1 will be the first value, 21, s2 is 42, s3 is 5, all the way to up to s10. S10 will be 52. Now, if I want to find the sum of all of them, then I'll use the sigma xi, which means the sum of all the values. So that will be 290. So this example is to help us to understand the notation. So lowercase n is the sample size. Uppercase X is the variable of the data set, if it's about age, about height, weight, etc. Then S1, S2, etc. will be individual values of the variable. And sigma symbol is for the total sum, summation of everything. So we say central location. First thing we're going to do is how to find the sample mean. So we know a mean is the same as arithmetic average. Add all the values, divide by the number of values. This traditional measure of a central location, which again is the sum, all the values, divide by the number of values. In this case, our number of values will be n, because that's the sample size. Divided by uppercase N means we are dealing with the population. So the symbol for sample mean is X bar. The symbol for population mean is the mu. So let's see the formula for finding the mean. This is a sample mean, so we are using the X bar equal to 1 over n means we dividing everything by n. So we can see that the sum of all the values from S1 plus S2 all the way to Sn, n is the size of the sample divided by the n. So which means we are adding all the values from S1 to the highest, then we divide by the number of values. We can represent this using the sigma symbol, 1 over n, which means all our values divided by n. The sum of x values from 1 to n, so we have xi, the beginning of xi is 1, I is 1, all the way to the n is n, because we have xn, that is the last. So if I have 20 values, I'll say, okay, 1 divided by 20, xi, I equal to 1 to up to 20. So this is the first example here. Again, we saw these ages, 10 individuals selected with the following age, they are 10. So we know the sample size is 10, n equal to 10. We sum all of them, we get 290, add all the values from 21 to 52. We get 290, then we divide 290 by the size, the sample size, which is 10. So my sample mean will be 29. Again, we have 10 values representing 10 ages of patients. We want to find the average age of the patients. We add all the values, then we divide by the number of values, which is 10. So it will be 290 divided by 10, that gives me 29. So the idea of the mean normally is to find the central location of the data, which we can represent here as a pivot. So we can see that when S bar should be balanced between the data so that the left side and the right side will be balanced. One will not go up and one goes down. So here the pivot again balance, finding the central location of the data. So uses of sample mean, again, sample mean, the value of an observation drawn at random from a sample size can be used to predict population mean. And that's the main goal here. We will discuss this when we start the inferential statistics. If we're going to do a research in a city, taking the whole population or using the whole population data will be time consuming and to take a lot of time. And also to involve a lot of money, the funds will be involved. So most of the time as a data science or stat, we always collect a sample from the population to save time and also to save the funds. Now, when we are collecting data, there are so many techniques we can use. The goal is that we want the data to be representative, which means there's no any bias in the data set. If I'm going to do a research and I want to collect the data about whether we're going to support, the nation is going to support a bill that is being passed by a Republican or Democrat, we will make sure that we go to an area where there is even numbers of Democrats and Republicans. Otherwise, there will be a bias in the data set. So this is the population mean. As we said, we use the symbol mu, but again, the formula is the same. Sum all the values in the population, then divide the population size. The differences here is that the notations or the symbols changes. So here we divide by the uppercase n. Uppercase n represented population size. Lowercase n represent sample size. but the formula operations are the same. So next we go to the median. The median is a little bit different from mean. So median is the value with a depth of n plus 1 divided by 2. Median will help us to find the middle of the value. We don't care how big the starting value is, how lower the end value is. It doesn't matter, but we want to find the middle of the value. Now with median, first thing we need to do, we have to sort the value in an increasing order. After we sort finish, we take the middle value. Otherwise, if the middle value is 2, we take 2 middle value and we find the average of it. That means we had a 2 middle value divided by 2. That's what we see a formula here telling us. But we'll see an example what this means. If I'm looking for a median and I have 3 values, okay, my middle is only 1, the second value, because I have 70, 80, 90. So 80 is the middle value. It's in increasing order. First, I'll make sure it's order. But now if I have a data, 70, 80, 90, 100, I have 4 values. There's no one single middle. So I will most likely take 80 and 90 and find the average of the 2, and that will give me the middle. Because we have 70 at the beginning, 100 at the end. 2 middle values, 80, 90. So I'll do 80 plus 90 divided by 2. Then from there, we can find the middle value. So we're going to see an example soon. So look at this data set given to us. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 values. If I have 10 values, then we can see where the arrow is. The middle value, there's no one single unit middle value. I can't take 27. Otherwise, we have 4 to the left, 6 to the right. So what we do is that since this is 10 values, we take the 2 middle values, which is 27 and 28. So we find the average of 27 and 28, which will give us 27 plus 28 divided by 2, and that will give me 27.5. You can see that the data is already in an increasing order. It's already sorted in an increasing order or ascending order. 0, 5, 1, 1, 2, 1, 2, 4, the way to 52. So we're looking for median. The first thing we do always is to sort the value before we get the middle value. Now, if these values are 9, let's say we don't have 52, that's easy one. The middle value will be what? 27. 27. Because we get the first 4 values, 0, 5, 1, 1, 2, 1, 2, 4. The last 4 values, 28, 30, 42, 50. So the middle value is only 1, 27. So always, if the number of values is odd, we can get 1 middle value. If the number of the number of values are even, then we may get 2 middle values. So let's see these examples may help us, as we said earlier. Here I have 2, 4, 6. It's already sorted. The median is 4 because the middle value is only 1. Next, I have 2, 4, 6, 8. It's already sorted. The median value will be 4 plus 6 divided by 2. So we get 2 middle value, 4, 6. So find the average of 4, 6. And that gives us 5. Now I have 6, 2, 4. 6, 2, 4, the middle value is not 2. The middle value should be 4. Why? Because we have to sort it first. So we get 2, 4, 6, which is the same as example 1. 2, 4, 6. So the answer will be again 4. Here we say the median is robust. Why the median is robust is that you can see that we are not using the values. The only values we look for is the position of the middle value. For example, let's say we are in a city, or let's say a village, and we have 10 residents living in that village. But fortunately, we have one multi-millionaire who is worth over, let's say, $1 million. The rest of the 9 people don't have nothing. They don't have no job, no savings, 0. But if I want to find the average, I'm going to say 1 million plus 0, then I'll divide by 10. because we have 10 people, the 9 is 000, so I get 1 million. Now the average income will be 1 million divided by 10, and that will give me 100,000. So I'll say, okay, this village average worker make 100,000, but that's not correct. That's not true. It just happened that one person have 1 million, the rest have 0. Now, if I'm looking for the median will be 0 automatically. So median is very good. They are very, very robust. That's what we mean by robust. They are very robust against outline data. Outline data means if the value is too large, in this case, 1 million against 0, or maybe too small. Let's say 10 million against 5. That will, again, if I'm looking for mean, it will have effect. Large value will have effect, small value will have effect on the mean. But with media, it doesn't have no effect. That's why in the real world, for example, in the business world, when we say, okay, what is the average income of adults in New York City? We don't say the average, we say the median income. Because the mean in New York City will be very high, because there are so many workers in Wall Street that are making over millions of dollars a year salary with bonuses. And then most people in New York make somewhere between $50,000 a year. So if I use the media, it's very good. It will reflect it. But if I use a mean, I mean, I live in New York City and my average salary is 100, but actually most of us are making less than 60,000 a year. So that's the whole concept of a median is robust. They are very good against a very large or very small values among the rest of the values. So next we go to the mode. The mode is the most commonly encountered value in the data set. Normally we find the mode of a data set if the data set is nominal data. For example, the number of yes and no, the number of short, tall, etc. Which means the value, we cannot find mean, we cannot find media, so we find mode. Mode is like counting, so we count. So let's say example is given here, data set as a mode of 7. Why? Because the highest tally is 7. If I have 4, 7, 7, 7, 8, 8, 9, the highest tally or the highest frequency of the same data is the mode. Now, if I have 4, 6, 7, 8, since all the values appear once, we say there's no mode in the data set. But if I have 4, 4, 6, 7, 8, then the mode will be 4 because 4 appear twice. So what is the effect of skewness on the mean median mode? First of all, we should know what is a skewness. Skewness tells us how the distribution of data is shaped. But there's a formula to find a skewness, which is the mean minus the median divided by standard deviation. And the skewness values is always between -3 to +3. So we can see that anytime we have a distribution of data and the data is symmetrical, symmetrical means we stay at the center of the data. What is to the left is the same thing to the right. This means the mean and the median mode, they are the same value. They are the same. But if we skew positive means you can see that the tail of the distribution goes to the right. This means the mean is greater than the median, or I'll say the median is less than the mean. And we can see that the mean go forward, median comes before mode. But here, the first one, they are all in the same point. So if we have a symmetrical data set, mean, median are the same with the mode. Now, if it's skewed to the positive, to the right or positive, then the mean is greater than the median. If it's skewed to the negative or left, then this time the median is greater than the mean based on the formula. If I skew to the left, you see that the skew value will be negative because since median is greater than the mean minus median will give me a negative value. So that's why we say negative skew. Positive skew, which is skewed to the right, my skewness will be positive value because it will be mean is greater. So mean minus median will give me positive. And this is what they're telling us the same. So if mean is equal to the median, then that means we have a symmetrical distribution. But if mean is greater than the median, then we have a positive skew to the right. But if mean is less than the median, then we have a negative skew to the left. Okay, so this is where we're going to end these lectures. In these lectures, again, we learn about the central location of data set, how to find the mean, median, and also the mode and what they are. Next lecture, we are going to discuss about the spreadness or the variation of the data set, which is how to find the range, variance, and also the standard deviation. And thank you.